I don't know why I came down here without my coffee cup, but I did. This is going to be a test. I now have my iPad set up here to try and film in front. And I have up here a webcam set up. There's the middle right there to try and catch the overhead. And I think I have it set like you're me sitting at the desk. I.e. like here is the front of the desk and so on. Over here is my computer on this side up above the iPad. So anyways, I got the light up here. There's a fluorescent light that I have turned off. I just went running up the stairs, get my coffee, catch my breath. So, all right, lesson learned there. Don't actually start recording after running up and down stairs. I really need to start walking more. Anyways, I got my coffee right here. So now we can actually try and do something. Let's see how this video holds up. iPad is down here. I'm looking at you right now. Right there's the iPad. I will get the real OBS. I thought I had paid for the OBS camera for iOS, but when I wasn't using it, I must have canceled it. That's probably what it was. But anyways, I've got this running into OBS Studio, and I got a webcam up here running into OBS Studio as the sort of overhead, and then I've got me on the side. Hopefully both come through. What I need to do is get another adapter for this. Oh, you can't actually see the webcam in the iPhone. That's interesting. I might have to readjust that a little bit, huh? So you don't see that. Oh well. Anyways, I sort of taped it up with electrical tape right now to hold the camera onto it. So I order a part for that, and then I'll have my third camera. And the third camera is just going to be my phone. That'll be my sort of, I can take it around with me, or I can put it on the side back here and do the sort of wider shots of the entire lab and stuff like that. But for now, this is a good start. So anyways, what I have in front of me is, I have the schematic for this. It is the, I can't remember the name of the company, NLS, whatever that's, God, I can't remember the name of the company, Near or something Systems. Anyways, it is a little oscilloscope that I picked up at the computer fair, Midwest Computer Festival, sorry, VCF, Vintage Computer Festival, Midwest version. Got that over the weekend, and it is the MS-230. I made another small video about this mini scope, and what I have right now, and I'm going to go through what I figured out, is this. But what I'm going to do right now is, now that I have the schematic sitting down here and can see it, I'm going to try and turn this light on and see which actually looks better in the video when I upload this to YouTube. Ooh, bright, hurt. Yeah, it kind of hurts right there. I wonder if I can adjust that. Nope, that gets worse. Put it up more. Change some. You know what? That might work. And if I change, I need a longer cable on this. We'll see how it is. Anyways, we'll see how it looks like in the video. But up here is that fluorescent light, which I got to work out lighting in here. I'm nowhere near there yet, so hopefully soon. Let me try one more light. Let me turn it on and we'll see what happens. That might provide some backlight. I don't know. We'll see if that helps, but I want to make sure I'm looking. I should put something like on the iPad to make sure I'm looking at the camera. I keep hearing everybody say it's important to make sure you're actually looking at the camera and not at yourself or something. But we'll see. Right now I am looking. Yeah, you can see my eyeballs are kind of off to the side. I'm looking at the actual, like I'm looking at myself in what is a monitor basically, and not the camera. So there's the camera. Anyways, I'm going to look over here to see. Anyways, back to this. This is the schematic for, I need to move some of this stuff out of the way. This lab has gotten out of control quick. It's only been like, what, a year since I've set this up? Not even, like 8 or 9 months, and it's already a freaking disaster. Little quick background. Basically, when I put this stuff down here, all of this other stuff was all around the house, in storage, in other rooms, in the garage, in other places. And when I built this lab, I just basically brought everything I had together in one spot, and it's not spread all over the house anymore, which honestly is really kind of nice too. Like the upstairs doesn't have a soldering iron sitting in it. But anyways, I digress again. So I got the, let's write this down. This is the MS-230 mini scope. I have no idea how long this video is going to be. We'll find out. What I have figured out so far, and there are 2 revs of the board, of the main board inside of here. If you look on this thing, we can see down here, where is it? Right there's the number. It is 41-196E. There's a number right down here. 41-196E. This unit is serial number 3146, which is also etched into the back of the unit, so I know that's correct. Now, I have 2 of these. I picked up 2 of them at the Vintage Computer Fest. One is a lower serial number, it's like 1200 and something. And that one, the board is 41-196A. What I don't know is if this schematic right here is for the A or the E. I can't find it anywhere on here. Of note, if you look on this E one, there's a bodge wire right here that I'm not sure what it goes to, but I think I've tracked down what these numbers are of these pins, so I probably can. And this is U13. Looks like it's either pin 1 or pin 14 on that one. I don't know which way it's in. I think that's pin 14 on U13. But anyways, the bodge wire, where was I starting with this? Oh, yeah, the schematics and which version it is. So I've done some tracking, but I think this is for the E. We'll find out for sure after we trace some stuff. But, I don't know, one thing at a time, right? By the way, I have not plugged this thing in yet. I do have a power supply, so maybe I should go to the power supply. Well, let's go back to the schematic here, because that's a great place to start. What it has laid out down here, these I've circled or highlighted the power sections. And what's interesting is right here, I can see why all these YouTube people have pointers. I will use a pencil right now. And you know what? Do I have anything that would make a pointer? No. Well, let's see how this works. What do I have? Got that too. I got that. Let's see. How does this work as a pointer? Can you see? It looks like a dental pick. I don't know what else I have as a pointer. One of those little fingers. I can't remember who the YouTuber is. He has a little finger that he uses to point around his stuff, which is really cool. Let's try this. This is, does this work? That's a little too big. I could probably make something too, couldn't I? Yeah, go to the shop, make something. I need some background music. There's no background. I can't play any music in the background because we know YouTube, right? Anyways, back to the schematic. Power sections. So over here, if you notice right here, this section right here, it actually says 150 volt AC. Here's the transformer T1 that goes back to your line voltage, and it says 115 volts AC. There's a part number charger unit 41-184-1 or 41-184-2. Dash 2 is the 230 volt AC version. The 184-1 is the 115. That's what I have, that version. So over here is what appears to be the charger unit, and I use the term charger specifically. It's not technically a power supply. It's a charger because there's some batteries in this unit. So let me grab the transformer. And what's great is this was the 70s, so it's literally just a transformer. It's a brick. So we've got a transformer. There's a couple of diodes in there, and they're both connected to either side of the transformer. And the the middle one is going, well, it doesn't look to be, I can't tell in and out. It's soldered somewhere. Something's soldered to it, so it's going somewhere. My guess is coming in, right? So, transformer, you got the 2 sides of it, and that's all that's in here. And this says it puts out, right there, as you can see, 10.7 volts DC. Very specific, 10.7, not 10.6, not 10.8, 10.7. I have not tested that, which that's on my list to do too. I got to put it up. But my oscilloscope's dead, so I'll just have to use the voltmeter. So, transformer down here. Now, what's interesting is this. If you look at this transformer circuit right here, there's a bridge rectifier right here, which I expected 4 diodes, bridge rectifier. Now, what I don't see are 4 diodes inside of this transformer. I only see 2, and I'm not sure why. Yeah, I don't know if I can get down in there, but way down in here, attached to either side, there's a diode here and a diode here. I can't get this transformer out. I haven't figured out. I haven't brute forced it yet, which I might, just so I can get a part number off the transformer. Sorry, off the diode, because there's nothing marked on here. It's just C, CR2, CR3, CR1, CR4. So I'm assuming is a rectifier. If I can get the transformer out of there, it feels like it might come out, but I don't know. What's holding it in? I'm assuming. Anyways, deal with that later. But, so, step 1, like going right back to the beginning where it starts, the power coming in, transformer, rectifier, I have to figure out why there's 2. This looks like a rectifier. So those resistors aren't present in there that I could see either, which makes me, now what's interesting is they have a line around here, like this is the transformer, and it includes those resistors, and I don't see those in there, which maybe they're in the -2? I'll have to do a little more research on that and figure out where those are at. But we got a plug here and plug here. That's those 2 coming in. So, end result, boom. Transform 10.7 volts comes into this low voltage power supply assembly. And there's a 41-203 number on this right here. I looked on mine, and this is a board in the back of the unit. The low power, low voltage. If you see, that is this board back here. And there is a part number on that. Where did I see it? Mine is 41-202B, which I marked here, 41-202B. This is 203, so I would guess they changed the power supplies at some point, or the low voltage board, and incremented the number up to a 203 part number, which of course immediately means this schematic does not completely match the unit I have. I have not looked at the other one, but it's actually older, so looks like this is newer. And notice on here, nowhere do I see the board number that was on the bottom, the 41-196E. 41-19, no, I don't see it anywhere. Unless I haven't looked at the whole thing yet, it might be somewhere else. So that board on the back, point being, board on the back, this is the low voltage supply. There's a fuse right here coming in after this voltage regulator. There's 4 voltage regulators, and they connect back to this, I'll call it the main board, which you can see is actually going up to the high voltage. So we make it through. There's a plug here that goes up to the power switch. I gotta track that down. And notice right here are the batteries. And this is the battery set. There's 3 2-volt batteries in here that I found replacements for, and I will get. But for now, I'm just tracking all this out. I don't need them at the moment. So you notice, come back in, there's the batteries, red, black, the wires going in. So my guess is this part, there's voltage regulation coming in here. So we got 10, and there's an op amp right here. I can't, LM301 I think is the number on this op amp. I got to print the spec sheet and read that over, but printer isn't working on Windows. Yeah, thanks, Josh. It's your fault. It comes up. I'm just not sure if this is the charging section or if this is the charging section. From what I've read online, you have to have the batteries in. It won't operate without them. And it takes, well, I read in the manual, it takes 16 hours to charge them fully when not in use. And they last for about 30 minutes. So typical 70s. Takes all night, you get like 10 seconds. All right, cool, thanks. And you'll like it. So you come up here, and anyways, somewhere in here, I just got to go back. I need to pull up my book on some basic power supply stuff and remember the sections of a power supply and start tracking this out. End result is you come out here and then you connect in through these connectors right here. These are numbered down through there, and those are on the board. That is these things. It's just not metal thin, Darren. Or these connections here. It's like 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't know what 1 is, but I tracked all the other ones down. And that connects to this board, which, from what it looks like, notice they just run straight over to here, to this board from there. And so I think this second part on the back, this next rear board that is connected on here, move it over there so people can see it. This board here is the high voltage regulator. And it makes sense because look at the components down there. There's a bunch of capacitors. There is one IC. And note that these ICs are socketed. The other one that I have, the older one, was not socketed. So either they changed this large, I'm assuming it's a logic board. They changed that to include sockets, or somebody has been in here already. And I think that might be the case. The reason I say that is the bodge wire, the solder job on one of these sockets doesn't look great. And I think I see a couple of caps that have been replaced. But I guess it could have gone back to the factory for service too at one point, and they fixed it, and maybe they upgraded this to be the newer one that's on the schematic as a later version. I suppose anything's possible. Interesting is this company, NLS, something linear systems, new linear systems, maybe it is. They are still in business, still in California, from what I remember. Which maybe we'll throw that up on the screen here when I edit this out. And they just don't make this anymore. But I'd be curious if I called them what they actually said. If I said, "Hey, I've got 2 of these. What do you got left around?" I wonder if anybody. I'd love an original schematic if they had one. I'd definitely pay for that because this is hard to read stuff on. An original manual would be even cooler. The guy that I bought these from, he had 2 other ones, and one of them had a nice little field case that you could put the unit in, and he had a printed manual. Oh, and the field case was nice leather, and it was definitely high quality because this was designed as a field unit you could carry with you. You carry 2 of them, and you got an hour's worth of use. But anyways, the company's still in business, so it's entirely possible that things came back for service, and I guess they supported them up until like the late 80s, early 90s. Maybe even a little bit longer that they serviced the units at the factory. So it's possible it came back for service. Would be interesting to know. Track the serial number with them, maybe. Thermal paste is coming off. And the thermal paste is still good from 1980. So that's the other one. I got to start looking at these chips and get some date codes and figure out about when this was made. I'm curious to put a date against it. So back to where I started. Again, sorry, roundabout way to get to. I think this is the board that is the higher voltage supply to drive the cathode ray tube, which kind of makes sense. Low, high, logic. I'm not sure what these 2 little daughter cards are. There are part numbers on there. I'll have to find those. And then there's the board on the very front that to display it carries all the controls and whatnot. So nice. I mean, cool little design. I really like this little thing. It's really kind of fun to work on this. But as I was mentioning on the bottom of this board, there are 8, 9, 4, 5, 6, 7, and 2, 3. So I don't know where number 1 is on here. It goes off to somewhere on the board. But down here is 2, 3, 6, 7, 4, 5, and 8, 9. So 8, 9, 4, 5, and 6, 7 carry through to the high voltage power supply assembly, which 41-198 PC80 maybe, it looks like. I'll have to look for sure. Unfortunately, I can't get down in there to see that part number without desoldering some components. So to get to this, so there's some bolts that go to the back to hold. There's a big heat shrink that goes, or heat sink that goes in the back. But to get to this board, you have to desolder these down here in order to see what the part number is on there. Unless I can somehow find it down this way, which off camera I will dig at some point and just see if I can find that. It would be interesting to know. Looks like is that transformer? Looks like that's the transformer in the higher voltage. And there is a chip here, so I'm not sure what that chip is. I'll have to look. All right. another full bridge rectifier. So I'm guessing we're going to come in here. It looks like this is +5, and I think I saw +7 somewhere in here. But if we're coming off the back of these 3 batteries right here, so we got 10 volts coming in. Step it down a little. Probably, I think it's what this resistor, these 3 resistors for. They probably step it down, and then we come into the op amp. I'm guessing that op amp controls the recharge, is my guess, along with these 3 transistors. More to come later, figure that out, unless you happen to be watching and you know. There's a fuse right here on that line, and here's the battery. So I'm guessing this recharges along with that. If I could figure out what that op amp does, then I'll put it over there. But then you come in, and it looks like at this point, so these are 2 volts each in series, so this is 6 volts coming off here. And I'm guessing you could just take the 6, and it looks like it just brings it down to 5 volts over here on this side coming out. I don't know what else you'd need inside of here for voltage. I thought I saw, here it is. So right here, this is +5, and this says 7V right there. I'm not sure. It doesn't appear to be connected to anything other than down here through this plug and a 330, was it pico? Is it? I can't tell. It's like a 330 picofarad cap there. So 7 volts coming in. Some down here to that. Gotta figure this part out here. Unsure what that does. But and that's through 2, 3. Oh, is this number 1? No. So it's number 2 and 3. They come down here. Looks like to the yeah, that's the other side of that rectifier. Interesting. I'm not sure what that one does. There's a diode coming down there. I don't know. +5 volts. I'm guessing that is. I don't know. I don't know enough about transformers yet to understand what this is doing here. All I do know is we got somewhere 5, 7 volts coming in this way, and then this is stepping it up. So the high voltage, I saw somewhere up here a 700 volt line up in, no, 100 volts. I unfortunately need this to see some of this stuff. It's so small. I would love to have a larger version of this thing. But coming in, so here's the high voltage, and this is obviously the CRT, the display right there. That's driving off the high voltage, and of course, all the signals coming in here. Not sure what happens coming in here. There's some connectors from this board, and that's 1, 2, and 3. So there are, I'll have to track them down on the board. That's more of those pins that are coming through from board to board. I'm guessing these are the pins that connect this board to what is probably the control and logic board over here, or boards. And I think this is a separate board. I think this is a board, or those 2 small boards that are subboards connected in. I think those are down here in these 2. Although they might be separate boards for each channel, because this is a 2-channel scope. I don't know. All I've got figured out is power comes in right here from the wall, feeds in through here. I think that recharges the batteries. Batteries come out by 6 and comes down to 5 volts. Goes into the high voltage power supply assembly, which drives this. I'm assuming somewhere on this, there's probably voltage coming through to drive the logic from the power supply. Well, there would have to be. Well, what do you do without power, right? And somehow power's getting up to here. But on the MS-230, that is what I have so far. I'm going to make another cup of coffee, go watch some other YouTube videos, and I'm going to try and get this uploaded right now. See you later.